So on to the second page. When you're designing an experiment, you figure out, okay, this is what we want to test. This is how we want to test it. What's going to mess us up here? What's going to mess with our results in a way that could change them, but isn't actually what we're testing? It's not our variable. And as many of those as you can think of before you actually set your test up, as many of those as you can kind of fiddle around, makes for a better, smoother running test. So I'm going to run you through a few potential tests here, and we'll see if we can't puzzle out the confounding factors and figure out whether we can do workarounds for them. A lot of times just your design will work around them. So we developed a chemical that we want to market as eye drops to relieve eye strain. And now we can get a bunch of people into the lab and poke them in the eye with a pencil eraser, right? And put our eye drops in. Is that a viable test for what we're trying to do here? Would you say that's a good test for something we want to? It doesn't really mimic what our real world application is, does it? There's also a huge confounding factor. I take you into the lab and poke you in the eye. Your eye's going to hurt. What's your other reaction going to be? Aren't you going to be pissed at me? Yeah. And you don't want your whole test group to be angry with you when you're trying to get, good information from them. So that's not really a good test. We can do it in a lab. We can have all sorts of parameters we can set. But this doesn't really work well in a lab setting. We got to go out into the real world where the eye strain really is. So you'll come up on this in when you go through the lectures. This has got to be done as a field test. Field tests are things that really have to be done in the real world for a number of different reasons. Sometimes it's the only way you can find the stuff that you're trying to test. Sometimes it's too expensive to do it any other way. Sometimes it's not ethical to do it any other way. But this is definitely a field test. We got to get out to where the eye strain is in the real world. So we're going to rent ourselves a suite in a big office building. And we're going to put out an email to all the workers in the office building. We are down on the 3rd floor. We've got it cleared with all of your supervisors. If you're having trouble with your eyes, come on down. We're testing our wonderful new type of eye drops. So people start to filter in. We go, design. Let's run this for 2 months. Because you got to figure out going in how long you're going to do it. So people start to filter in over the first few days, and you sit them down, go, your eyes are bothering? Yeah. How badly are your eyes bothering? Oh, pretty bad. Not as bad as yesterday, but pretty bad. And the next person is, bad enough I came down here. It's not super bad, but how do we compare those two people for how bad their eyes are? What do we got to do here? How do we measure eye strain in a way where we can compare one person to another person?
Allergies or eyesight?
Well, I'm not worried about the explanation for their eye strain. That actually may be a confounding factor. Right now I'm talking about how do you measure it?
Having them rate it on a scale of 1 to 10.
Convert it to numbers, right? We do that all the time. Eye strain is a qualitative feature. It's on this sliding scale of pain, but we can force it onto a number scale. So what number scale do we want to use?
1 to 10. 1 to 10.
What's the bottom? If you're measuring pain?
0.
Yeah. And that's something you got to think about. If you get something that can be not there entirely, then you probably want to 0 your scale as opposed to starting at a 1. Because you figure they're coming in, they're going to have a number. But maybe when they're done, they're not going to have any eye strain at all. So you want that 0 on the scale. And now we can compare the first guy's 4 to the second guy's 3. Even though we can't be absolutely sure that the scale in their head is the scale that we want them to have, but it gives us a better, and people will understand it. If we go, so we did 100 people, and on average at the end of our test, they had dropped 4.3 scale pain points on the scale. Well, that's, you kind of understand a 0 through 10 scale, that it's working okay, right? We're gonna do this. We're gonna bring them in, we're gonna interview them. Do we worry about where the eye strain came from? Do we worry about, getting a piece of stuff in your eye or having allergies? That's something you gotta decide going in. If you decide, okay, somebody got something in their eyes, that's not really eye strain, we don't wanna count them. We're not gonna count, we'll treat them with the eye drops, but we don't wanna count them because that's not really what the eye drops are for. Or you may go, that's absolutely what we want the eye drops to be for, and we will count them. But you don't wanna be making those decisions on the fly. And you're gonna, but going in, you try as much as possible to decide, does the cause of the eye strain matter? Are we gonna exclude some people because of what's making their eyes hurt? And we decide, no, okay, we're gonna take everybody. So we sit them in a nice dark room, little chair that leans back, put our eye drops in, let them blink a few times, pick their number up. What's your number like now? Go sit in our recovery room for 10 minutes. What's your number now? Okay, go back to work. We're gonna call you in an hour and get another number from you. Next morning, we're gonna call you. We're gonna get a number from you. And we're gonna ask you a weirdly open question. What are we asking them tomorrow morning? We probably should have asked them that as we went along, too. It's a drug test. What's one thing you look for in a drug test? This was on the news yesterday when they shut down the Oxford test for a while. Somebody had a very bizarre, fairly rare condition pop up. And they didn't know if it was a side effect or not. So we want side effects as well as effects. So the next morning, we're calling people and going, how are your eyes today? What's your number? Anything unusual between yesterday and now? What do you mean? Anything. Yeah, I had an accident on the way in. Oh, how'd that happen? Okay. You listen to it go, that probably had nothing to do with his eyesight, so that's probably not. But you gotta ask a really open question because you got your 100 people. When the 15th person tells you that they had dreams about lizards overnight, you start to think, this kind of sounds like a side effect, because that's weird, and now we're up to 15 out of the 100 people who had dreams about lizards since we put those eye drops in. And that's the weird thing. You wouldn't have expected that to come from your eye drops. Maybe their feet hurt, but you're looking for side effects and then trying to figure out whether the effects you're getting are really side effects from your treatment. But you gotta figure that out. Because side effects will have an effect on your results as well. This one, possibly two people with this odd nervous system issue may shut that whole vaccine trial down. Right now it's just on pause. They're trying to figure out whether it's really related to the vaccine. So we've got our people, we've got our data, we've got a 4.3 drop on average on the scale. Does that mean that our eye drops work really well? We didn't do something. What didn't we do? This came out of the last couple of questions. What do you use your variable to do? We don't have a comparison, do we? We don't have a placebo group. Our design should have included, somebody comes through the door, if we did it right, somebody sets a little pinger off on the door, and your computer goes blue. And you give them a dropper from the blue bottles that you have a whole bunch of. You've got blue bottles, you got yellow bottles. The computer is randomly assigning everybody walking through the door 50-50 to one or the other treatments that you had packaged in your lab, but you didn't package yourself. One of those two bottles has your chemical in it. The other one just is a nice saline solution. And you don't even know which one it is, because if you know, that's possibly a confounding factor. We're doing a double-blind experiment. They're not gonna know. Somebody's gonna go, well, yeah, but if they see blue versus yellow bottles, is it gonna have an effect on the way they react? And you go, crap, I don't know. Maybe we need to just put a blue dot on them so that, a little thing we can see and they aren't gonna notice. That's a possible confounding factor though. Does color matter? Who knows? We can design the bottle so it doesn't. It's not a factor. So we run our 100 people, 50 of them get treated, 50 of them get a placebo. Our treatment arm drops it's a slightly smaller group. Say they drop 4.1 on the 10-point scale. Our placebo group drops 3.9. Does that mean our drug is doing a lot of good to anybody? Just seems like, comparison-wise, just putting something wet in people's eyes and treating them is maybe helping their eye strength. So we absolutely positively need a placebo group for a comparison. Because you can imagine, somebody being nice to you, putting a nice dark room in a comfy chair and putting drops in your eyes, it's gonna show an effect. Placebo effect. Okay, there's one huge confounding factor for this particular design. I kind of set it up for you when I was setting up the experiment. Anybody notice it? What was the first thing we did when we moved into the building? He gets very excited. We put an email out to everybody, right? What did we tell them? Didn't we tell everybody in the building that their supervisors are fine with them taking an unscheduled break if they come down and work with us? Is everybody walking through our doors really walking through with eyes that are bothering them? One would assume not. Some people are just going to use it as a place to take a nice break. Are their eyes going to get better? If you were faking it, wouldn't your eyes get better when they ask for your second number? We can't trust that. Is there any way to keep that out of our experiment? There really isn't, is there? The best we can do is hope that our experimental group and our control group have an equal number of liars. And the numbers kind of wash out because they're balanced between the two groups because they're randomly being assigned. But that happens sometimes. You get a confounding factor and you look at it and somebody goes, well, put them on a lie detector. I don't think that's really going to be effective for what we're trying to do here. Ask them if they're lying about their eyes. Well, yeah, that'll work real well. But there isn't any good way to address that particular confounding factor. It's just something you got to live with. And that often happens in design, where somebody will go, well, what about this? What you hope will happen is somebody will go, what about this? And you can go, yeah, we thought about that, but we decided this or this or this. It's much better than somebody going, well, what about this? And you go, oh crap, we didn't think of that. Our whole design is flawed. Okay, next, you're right. You don't have to write absolutely everything down. Just make sure you get answers down for this stuff. Our next experiment is another applied science experiment. We're trying to eventually sell this thing that we're developing. And in this case, it's a new birdseed blend. So we're going to test it. What's our variable here? Well, we don't necessarily have an old blend. We may be new to the business, but I know what you mean. Another blend, right? So it's the blend itself that's the variable. You didn't fall into the trap. A lot of people go bird seed. But the bird seed isn't the variable, because you're not gonna run a test with your blend in this test with no bird seed. You're gonna vary the blend, which you can do. So we're gonna do a comparison. Would you trust us if we whipped up our own other blend to test against? I don't think I would trust somebody that did that. But there are other blends we can get, right? Then we have to decide, do we want to test against the most popular blend on the market? Do we want to test against the most expensive blend in the market? You may go, let's do both. And then you go, well, what if we do better against one and worse against the other? In the real world, you go, well, then you ignore the one you did badly against. You just sell based on what you did well against. But you gotta be careful when you're designing your own experiments that you don't measure too many things, because then you've got to figure out, well, what if this gets better, but this gets worse? How do we factor these two things together? So for your experiments that you're eventually going to design, you want to measure and focus on just one kind of measurement. Or otherwise, you've got to do a lot of explaining as to, well, you know, what if their colds are worse, but they get over them sooner? So is this a good thing to test in like a big enclosure with a bunch of birds? Is that really a test for how this is going to work in the real world? Sounds like another field test, right? We got to go out in the real world. People are going to be putting these in bird feeders, right? We got to go out and put them in bird feeders. What kind of factors are going to have an effect? Well, no, let's back up. So we're going to put bird seed in the bird feeders. At the end, we need data. At the beginning, we need to decide what that data is going to be. It really comes down to, so what are we going to count? What are we going to count to decide whether our bird seed is better? So number of birds. Okay.
Put up a camera, see how they react to it.
Well, that's how we would do it. Now, we're looking at video. The question is, what do we count? We can count number of birds. What's a confounding factor for counting number of birds?
Where you live,
Hmm?
where you live, or if you have like a lot of birds near.
Well, no, I meant purely for doing that as a measurement. What if the same bird comes back 10 times? You know how difficult it is to tell sparrows apart? So you're going to wind up probably not really counting birds, but counting visits, right? How many times does a bird come? Because somebody may go, well, yeah, but you want to know how many different birds you're getting. And you may go, well, from a practical standpoint, we can't do that. We can't tell them apart reliably enough to count how many individual birds. It used to be on the internet that all you could count was how many visits you got. And then they eventually designed software and you would see, you know, we got this many unique visitors this month because the software became able to do that. But for a while, it couldn't do it, so you just counted how many visits. So here we would count how many visits. Now, is that the only thing that people think makes a bird seed good? What else might we be measuring? Think of what your advertising might be claiming.
If it's healthy for them?
Hmm?
If it's healthy for the birds?
Nobody's ever suggested that. That's a whole different test though, right? If we're gonna test the nutritional quality of that, then we don't really need bird feeders and we need something that's much more in a laboratory sort of setting. Or we've got to do a heck of a literature search to figure out what bird nutrition consists of. Doesn't mean we can't do that, but it kind of takes us in a slightly different direction. So in terms of marketing, we can market the nutritional stuff, but we probably should have worked that out ahead of time. People are looking out at their bird feeders. What's gonna get them excited? Oh, there's a bunch of birds out there. What else is gonna get them excited?
Baby bird.
Yeah, but baby birds can't fly, so they're not coming to your feeders. Do you know what that is? I've never seen that before. We've never had that come to the feeder. Different types of birds. So we could be counting how many different species of birds we're getting. But that's a different measurement than numbers, right? And here's where it gets tricky, right? If we decide we're gonna measure both, what if we get bigger numbers but fewer types? Or more different types but fewer numbers? How do you factor those two in together? You can do it, but you have to figure out ahead of time how you're going to do it. You can't, if your reaction is, well, we'll measure those two things, and if one is better and the other one's worse, then we'll only pay attention to the one that's better. Or we'll factor it in more strongly, because now you're biasing your experiment. Is you don't want to be making those decisions at a point where you can kind of push your results in the direction you want them to go. People do that, but they're not supposed to. So, position. What can affect how effective our feeders are going to be? We have to decide on what our feeders are going to be, right? What's a confounding factor for a bird feeder? Nobody has birds?
The placement.
Yeah, but what is it about the placement that we have to be thinking about?
The location, the weather, the season.
Well, weather isn't really a placement thing, right? Weather is kind of more of a climate thing. And then you run into trouble where, now we run into funding issues. Ultimately, you'd want to do a full year, right? But who can afford to do a full year of a test like this? So you may be stuck with, we did it in the spring, or we did it in the summer, or we did it in the fall, and somebody goes, well, yeah, but what about the rest of the year? And you go, we couldn't afford to do the rest of the year. So that kind of, or do we measure on a rainy day? Right, that's a weather thing that changes day to day to day. And you may go, now, she was talking about setting up video equipment, however you're doing your observations, it may be that a rainy day is gonna really screw up what you're doing, and you go, we can't measure on a rainy day. Or somebody may go, well, the birds are not really flying on a rainy day, we're not counting rainy days, but you need to decide that going in. You don't wanna be getting up in the morning and go, wow, it's really raining out there, what are we doing? You wanna know that going in. But, now I have bird feeders, and I look out the window, and the birds are not the only thing on the feeders, right? That's a confounding factor. There are bird feeders that are much, much better at being just birds because it's, one way or another, they block other animals. And I've got feeders that, anything over a certain weight will close the portals on it. So it's at least squirrel proof. It isn't chipmunk proof, but it's squirrel proof. Chipmunk proof is a little trickier, but you can set it up that way. But you need to know going in, okay, these are the feeders we're gonna use because we want them to just be birds coming to the feeders. Any other kind of animals are confounding factors. How else can animals be a confounding factor? So we're using human observers. We're looking at their day-to-day numbers. You say, Jim, you're not getting any birds. Everybody else is getting birds. Why are you not getting birds? And he goes, well, there's this hawk that sits up on the wire right over where we've got the feeder. And they're not coming anywhere near there. Oh, we had no idea going in. This is why it's important that you don't just set up 2 feeders. You set up 20 with your blend, 20 with the other blend, try to locate them in comparable places, have a few under trees, have a few next to big windows, have a few near high traffic areas where people walk, but not just 1 and 1. Because if you only had, if that bird feeder was next to a window and you had your comparison feeder next to a window and the hawk is keeping all the birds off of one, you can't really use it or the other one for a comparison. You need a bunch of them, where you can just kind of average your results and kind of toss that one out. You know, because this lady's got a cat, or they've got a hawk, or, you know, this is, it turns out this on a road with these big trucks that go by and the birds are just not happy in that area. But you won't know until you get into the real world what the confounding factors are. Lots of numbers will allow you to toss your occasional feeder and still have a good comparison. Any other confounding factors for this? Okay, the next one's a weird one. It's based on a hypothesis that two sociologists from Chicago came up with a number of years ago. Through the early 90s and into the 2000s, in major urban areas, the crime rate, especially the violent crime rates, dropped precipitously. They really dropped quite a bit. And these two sociologists from Chicago said, I think we're seeing a lag effect on Roe v. Wade, the Supreme Court decision that said abortion should be legal everywhere. Women who were in poor situations were more likely to go and have abortions. And so those kids that they would have had didn't exist, growing up in these poor situations, getting into their teens with not a lot of options, and potentially turning to violent crime. So our potential, because what happens with violent crime typically, if you're a sociologist, is violent criminals tend to be mid-teens to mid-20s. Usually before mid-teens, they're not, you know, big and tough enough to bop people over the head and do things to them. And by the mid-20s, they've often moved on to other kinds of crime, and you know, they're not criminals anymore, but they tend not to be violent. They're saying, okay, here's the Roe versus Wade decision. Here's now a population of non-existent poor kids who would have been criminals here through here. So here's the crime rate, and there's the crime rate dropping, because the violent criminals who should have been there didn't exist. Weird hypothesis, right? And a hypothesis that basically was saying, here's a very positive societal aspect to abortion. So obviously there were a lot of people who very much did not like this hypothesis. They had what's called the null hypothesis. There's always a null hypothesis. The null hypothesis amounts to, you know your idea? I think it's wrong. That's what happens when you run your test and it doesn't go the way it's supposed to go. The null hypothesis goes high. It's always lurking up there. But the sociologists weren't really that interested in testing their hypothesis. They were sociologists. But the null hypothesis people very much were interested in testing to show that it didn't work. So what's the variable here? If you're going to test, you need a variable. It's not the crime rate. The crime rate's a result. It was abortion that they're claiming caused that drop. So if this is your variable, how do you vary it? How do you go from abortion being legal to not being legal? You could say, well, let's see where the abortions took place and see whether there's a connection between, you know, the availability of abortion and whether that area actually saw the low crime rates. There were some people that tried to do that. It turned out to be a very difficult thing to do because of a lot of variation in the records. And for a long time, you didn't get an abortion from an abortion clinic. You could get an abortion a bunch of different places that weren't always necessarily in the records. As it got more and more and more controversial, it tended to get more and more restricted to places like Planned Parenthood and things like that. So it's a good idea, but it turned out to be difficult to test that way. So, if it's not easy to find variations within the United States, what about going somewhere else? Abortion's been illegal all the way along in Italy. Could we compare, say, the crime rates in Milan to the crime rates in Syracuse? Is that a valid comparison? Are they the same cities? They're comparable? Now you run into confounding factors. People go, no, they're different in a lot of other ways other than abortion's legal, abortion's not legal. And that turned out to be a problem. You try to match a United States city to an Irish city or to an Italian city. There's too many other differences. People really didn't buy into that as a valid comparison. The one thing that turned out to be useful is that when Roe versus Wade occurred, abortion already was legal in several states in the United States, including New York. Now, not all of those states had urban environments, so not all of them had a drop in crime rate. Here's where we get predictive. If abortion became legal in New York 7 years before the Roe versus Wade decision, when should the crime rate have happened compared to the crime rates most other places? Shouldn't it have dropped earlier? If abortion became available earlier and it was connected to the drop in crime rate, shouldn't the crime rates have dropped earlier? That's your predictive part. And it turns out that's what they found. When they went to, I think, the 2 states that had significant urban areas and had abortion legal earlier, that the drop in violent crime rates happened on the same schedule that the sociologists predicted. It happened earlier. And eventually the people that really were trying the null hypothesis gave up trying, because every time they tried to test it, they either ran into trouble where they couldn't really put the test together, or the test actually showed evidence for the other side. But it did turn out to be testable. Okay, the third one is, is the third one or the fourth one? Fourth one. So I goes, oh yeah, in the old days, I got people coming over. I forgot to get ice. I got ice cube trays, but I only got a couple hours. And somebody goes, oh, well, you know what you got to do. You got to put hot water into the trays and put them into the freezer. They'll freeze faster. How many people have heard that? Nobody really? One of those, usually people have heard this. Now that's a testable hypothesis, right? What's the variable in your test? What's going to change from one test to the next? The temperature of the water to start, right? So we can vary that. We can start with, cool water, lukewarm water, warm water, hot water. You'd want to do a multiple test with multiple temperatures, right? If you just have, cold and hot, you get 2 data points, but who knows if that trend actually goes in between. So what are the confounding factors here?
Size and shape of the ice cube.
Okay, we want however we're doing it, we want all of our tests to be equal in terms of the ice cubes. We want the trays to be the same kind of trays. We want the shape of the cubes to be the same type of shape. Is that all of that should be constant. Because the only thing we want to vary is the temperature of the starting water. So how do we decide when the ice cubes are actually frozen? We're going to start a timer. When are we going to turn the timer off? Why'd you turn the timer off? Well, they're frozen. How could you tell? Nobody?
Put a thermometer in the fridge.
Okay.
Look at it, there's water
Well, in the fridge or in the water?
in the fridge.
But isn't
Oh, yeah.
yeah, it's in it. The freezer's going to be,
Yeah,
it's going to be pretty cold in the freezer. You could put a thermometer into the water, now the question becomes, when do you turn it off? When do you turn your timer off? You actually run into a physics problem. What will happen with the temperature in the water is it will drop and drop and drop and drop and drop, and it'll hit 0 Celsius, which is the freezing point of water, and it will stop there for a while. Because while the ice crystallizes, it won't get any colder. It's losing heat in order to crystallize, and it'll stall at that temperature. So you could time it to where it hits 0, but they won't actually be frozen at that point. But you could measure that, right? Because if it's coming down faster in our warm water than our cold water, hitting 0 faster, you go, okay, that means they're gonna freeze faster. You could also say, I'm gonna measure it when it hits -1, because the freezer's colder than 0. And when that water is completely frozen, that's the only time the temperature can drop below 0, so I'll measure it -1. Those would be two different measurements, but would it both measure the same thing? You would think it would. I've actually got in there, oh no, I took it out. I used to actually have a mark on the trays, because the ice expands when it's completely frozen, and you can predict where it'll expand to. You can put a line on the tray and stop it when it hits that line. But that's probably gonna be, numbers-wise, a different measurement than the other two temperature measurements. But as long as people look at your data and go, yeah, okay, that's freezing, I wouldn't have done it that way, but I understand how you did it, then you can measure it whatever way you want to, where you can convince people it was a valid measurement. Any confounding factors here? How do we see the thermometer?
Use the little camera inside the freezer.
Okay, so we need a pretty big freezer.
Yeah.
Okay. So, because it's a little freezer, we gotta keep opening it to look at the thermometer, that's gonna be an issue, right? That's a confounding factor. The fact that we're in the freezer with our warm bodies with the ice cube trays, that might be a confounding factor too. We wanna really bundle up so we don't lose a lot of heat to the surroundings. But you could probably set it up that way, especially a really big walk-in freezer. You could do it outdoors in the middle of February. The problem there is that the temperature around you will vary. But you could actually set it up so that, we've got our experimental group over here, and 30 feet over this way, out in the yard, we've got our control group. And yeah, the temperature's varying, but it's always under freezing, and so it's always having the same effect on the ice. But it does get tricky in terms of there are other confounding factors at play here. I personally have a hypothesis about that. I personally think that the only reason that this ever works is most people have small freezers that are fairly crowded, and if you put a tray of something hot in, it's gonna raise the temperature of the freezer, it's gonna kick the compressors on, and for a while, the freezer's gonna get actually colder than it normally is. And that may make the water freeze faster. And you could test that, but it's a different hypothesis. Okay, last one, that's another practical one. We wanna test a pillowcase fabric. We're gonna make pillowcases out of this fabric. And we wanna see whether people like it. It's basically a taste test variation, we want a comparison. We're gonna send our people out into the mall, now that the malls are working, although nobody's gonna come near us now. The old days. So they've got samples. We want people to try the samples. We've got our pillowcase. And what are we using as a comparison? What's the variable here? Just like the birdseed? Isn't the kind of the feel of it the variable? And how do you vary the feel in a situation like this? Wouldn't you use a pillowcase from another company? Again, then you have to decide, the most popular, the most common, the most expensive, whatever you're gonna use as a comparison. So you stop people as they go through the mall, and you go, you know, here, if you take our test, we'll give you like a coupon for something. You go, okay. How do we test the feel of the pillowcases? What do we have them do?
Survey.
Hmm?
The survey.
Well, what are we gonna ask them? Okay, how it feels. Now, can we come up with a scale for how it feels? And when somebody goes, what do you mean, how's it feel? Is it, what am I actually supposed to be, you know, where do these numbers come from? Huh?
Maybe several like different scales, like how firm the pillow is.
We're not testing the pillow. We're testing material we're gonna make pillowcases out of. We want, if we're gonna use a pillow, and that's something you gotta decide, okay, if we're gonna use a pillow, are we gonna make them lay down in the middle of the mall? Because squishing a pillow up against your face isn't necessarily a good measure. And we don't wanna do anything to make them feel too uncomfortable. And we can do just a straight up comparison, right? Feel this, feel that, which one do you prefer? And go with that, whereas you don't necessarily need numbers in a situation like that. It's an either, it's not a, that's a qualitative difference. Like, don't like, kind of difference. But is it okay to just give them the fabric and have them like rub it on their face? Does it need to be in a pillow? Does it need to be their face? Even though we're thinking of pillowcases, would it be okay if they just touched it with their hands? Because they may feel more comfortable doing it. Does it matter that the two fabrics don't quite look the same? We may go, well, that's great. We like that our fabric looks more expensive. We want that to factor into their decision. Or somebody else may go, well, no, because they're gonna be sleeping with their eyes shut. We just want it to be totally based on how it feels. And if it's totally based on how it feels, how do we hide how it looks? Put this blindfold on in the middle of the mall. Probably not a good choice. Anybody ever see a hide box? Well, under this cover, we've got two fabrics. Just want you to reach in and you know, touch them and then tell us which one you feel would be better. It's a pillowcase fabric, tell them that. Which one would make a better pillowcase? Does it matter if it's right hand, left hand? Most people are right-handed, does that matter? You go, well, that's a possible confounding factor, but we can swap, you know, swap it right and left in 50% of the tests, so we can kind of take that away as a confounding factor. Here's the tricky part, and sometimes they set up a test around this and sometimes they don't. So I'm walking through the mall and you go, would you come over here, we've got this test for pillowcase fabric, we got a coupon for you. You go, okay. Is it, would you put your hands in the hide box and feel the fabric and tell us which one you like. Go, okay. So I put my hand in there. And in my head I'm going, they feel exactly the same. What's the one answer I know they don't want me to give them? They feel exactly the same. They want me to pick one, right? And, you know, we're people, we like to please other people. We know if we pick one, we have a 50-50 chance of making them happy. So even though we don't have a preference, we may give them a preference. Not because we're malicious or liars or anything, but we just, you know, we know they want us to pick something, we'll pick something for them. Is there any way to design around that? It turns out there is. If you take like 25% of your tests and you put the same fabric on both sides, and 12% of those tests, they give you a choice, that means you can't trust 12% of your test groups. And you have to kind of subtract 12% from your other legitimate tests too, which is why people don't like to do that. But to make it really work in terms of that confounding factor, you really should put that in there. I will tell you this, when you're designing your experiments, You will have the options of doing, comparison tests. You do not need to do that. But if you do it, you gotta tell me how you're gonna factor it in. But you don't need to. As I said, a lot of times these preference tests, they don't do that. Okay, so that's that part. That was long.